Study was performed to determine if a training session for taking the math SAT test was effective. Students were randomly assigned to take either the training prior to taking the test or to not take the training. So the data below provide the results for the SAT test per group. So these folks took the training, these folks did not take the training. Here's the sample sizes and here's the standard deviations. So perform the statistical test to determine if there is a difference in the mean score of the two groups. Make your decision at the 1% significance level. Show your work and write a sentence to put your answer in the context of the problem. All right, so our null hypothesis was the training was not effective, right? So that the difference between the two groups is just due to random chance. So therefore, these two groups are basically equivalent to each other. So therefore, mu sub took the training minus mu sub did not take the training is equal to 0. The alternative is therefore that the training was effective. Let's see, did they want us to do it too? If training session was effective, okay. So we're going to determine if the training was effective. So that means that this group should have a higher mean than this group. So we'll go mu sub training minus mu sub no training is greater than 0. So since we're determining that it was effective, then this is just going to be a one-tailed test. Okay, so our assumptions, right? We have to assume that we have an independent, simple random sample with no outliers, and that we have the normality assumption. Well, we have to treat them as if they are an independent, simple random sample. Clearly, they're probably volunteers, right? Because they took the training or they did not, but they were randomly assigned to the two groups. So we've got the randomness part of it. We don't know if there's any outliers, so we just have to assume that there aren't any. The normality assumption is valid because our sample size is so large and is greater than 25. Okay, so our assumptions are checked. So now let's just perform the test. So our formula, right, is going to be, this is going to be a t-test, is equal to what we observed, so that's 504 minus 450 minus the null, which is 0, divided by the standard deviation, which is the square root of S1 squared, so 22 squared over 100, plus S2 squared, which is 15 squared over 100. And now we're just going to let the calculator do all the work. So we're going to go stat, test, 2-sample t-test, right there. And we have the statistics. So x bar 1 was 504, standard deviation was 22, sample size was 100, x bar 2 was 450, standard deviation was 15, sample size was 100. We were doing a one-tailed test, we never pool, and calculate it out. So my t-score is 20, so that t-score is gigantic. So we end up with t-score equals 20.28. The probability that our t-score is as big as 20.28 is approximately 0, right? 4.4 times 10 to the negative 48th. So we conclude the training was effective.